So the other sort of long-term problem solution is getting the energy collected by wind turbines into the power grid. So
yeah.
Still today, it's alternating current is the way pretty much all of them send their power, but now there's more press releases and articles about the potential to switch over to direct current. So you as an electrical guy, how do you find that? How does that sit with you?
So you go to engineering, specifically electrical engineering school, and the first thing they tell you is, hey, in order to transmit a lot of power, you need to cut down the amount of current because you're going to shove it through a wire. A wire is resistive. So the power loss in the wire is related to how much current you're shoving through it. So it's I squared R is the current runs through the wire. That's how much power is dropped in the wire. The resistance of the wire times the current squared. There it is. There it is. The problem is, and the way you solve that is you raise the voltage up really, really high. So if you raise the voltage up really, really high, you drop the current really low, there's less power dropped in the wire. Okay, that's what you're taught in electrical engineering school. Mm-hmm. The problem, and so the problem with doing it DC wise is you can't really get from, I don't know, pick a volt. 12 volts. You can't get from 12 volts to like...
No, 13 volts.
13 volts. 12 volts. 13 volts to 32,000 volts roughly. It's hard to get there without having some sort of electronic device to lift the voltage up that high so you can transmit it. Mm-hmm. That's a trouble. So because you can transform AC voltages and currents easily with a transformer. That's what Tesla invented way back with Westinghouse way back when. It's hard to transform DC into anything because it essentially takes electronics. And so until recently, in the last couple of years, we haven't been able to get to really high voltage enough where you could shove energy very far. But there may be an advantage to transmitting some energy via DC, particularly over shorter ranges. Probably is where they're going. It may take less copper to do it, but it also may have an advantage of making the cable itself less expensive, depending on how they set up. One of the issues with alternating current, because it's alternating, you get this sort of these magnetic fields that are set up, and you're creating and destroying these magnetic fields all the time. So you have this quote unquote reactive power thing going on. So there's some losses in reactive power that you don't necessarily have in DC. That's sort of the trade-off. So if you're really trying to get super, super, super efficient on transmitting power from A to B, it may be easier to do with high voltage DC. If you can get the electronics and the electronics are reliable enough to do it, that may be the most efficient way to do it.
Okay. So, I mean, as these get farther and farther offshore, into the 100 kilometers offshore kind of range, you still think it's AC or DC probably that far out?
If they can make electronics work, it's going to be DC. If they can make electronics work. That's going to be... Because think about any time you throw another piece of electronic equipment in the middle of something you really need. Putting a coil of copper wire in a bucket of oil, which is essentially what a transformer is, doesn't have any moving parts. There's no electronics. There's transistors involved with that process. As soon as you shove something electronic into this pathway, you have faults and failure modes that you just really don't have with high voltage transformers.
So on the HVDC trail, tell me real quick how it gets from wind turbine into my home to power this microphone. Where does it go? Like what? So people talk about a power grid. Mm-hmm. Just tell me the journey of this electricity to get to the power grid to get here.
So it depends how the generator's set up, but without getting too much depth in how power is generated, at some point at the wind turbine, it's going to get converted to, typically, it's going to get converted, it's in some sort of AC form, and there's transformers that raise the voltage up so you can transmit it down the line till you get to a substation, and there's capacitors you have to put on the line. There's a bunch of reactive capacitance issues you're trying to deal with to get everything into phase. So one of the things you don't want to do is connect up to the grid AC power-wise and be out of phase. It causes a lot of problems, and the power company will dump you off the circuit when they sense that happening. So from the wind turbine company's perspective, you want to be in sync with the power company. So you got all these wind turbines that are all generating power. They're coming to some sort of substation, and then they're syncing up with the substation and once the power company thinks you're cool and everything is right, they're going to hook you up to the grid and you're going to be part of the grid. And if you ever get off that, they just dump you, which is a problem. So what they're talking about now is you're sort of converting to DC at sort of quasi the base of the wind turbine. You're transmitting down to somewhere near the substation. You're converting that from DC to AC there. You're syncing up right there. It gets rid of a lot of line issues, capacitance issues you have to deal with, reactive issues you have to deal with as far as transmission line stuff. That's what they're talking about. So once you get to the grid, then you're pulling off, Dan, is pulling off the grid. You never see all this stuff that's happening behind the scenes back here. That's invisible to you because you've got this cascade of power companies and engineers and technicians making sure that your lights don't flicker. That's how they're doing it, is they're constantly monitoring that grid. So that's one of the issues with wind turbines and solar. The same way, which is you got to make sure you're delivering the quality product. It'd be like at a gas station, right? So I have a tank full of gasoline. I can't have the wrong octane or the wrong mixture in a tank where it has the right mixture in it. It's the same sort of thing. Like I want to make sure I'm delivering the right product at the right time so that my customer's happy. It kind of works like that.